In this video, we're going to look at synthesis reactions. So we'll start by writing out a definition of what a synthesis reaction is. Okay, and it's when it's a reaction in which two or more reactants combine to form a single product. So our general equation for this is going to be A plus B produces A and B stuck together. So the big identifier when you're trying to decide if something is a synthesis reaction or not is whether there's a single thing on this right-hand side of the arrow, one product. There are three types of synthesis reactions. Okay, we're going to be looking at metal and a non-metal. Okay, when something reacts with oxygen and when a metal oxide reacts with water. So first of all, a metal and a non-metal. Let's do an example, iron and sulfur. We're going to write out the word equation and then the balanced reaction equation. Iron and sulfur, both in their elemental forms, are going to combine to form iron 2 sulfide, which is FeS. So we've got one element, we stick them together to form a single compound product. Let's do another one, sodium and chlorine. So here we have sodium in its elemental form, chlorine in its elemental form. Remember, chlorine is a Hofbrinkel gas, a diatomic gas, so it gets that little 2. So sodium and chlorine, when we put them together, you're going to get sodium chloride. Which is NaCl. So I'm taking sodium, which is a 1+, chlorine, which is a 1-, crisscross. That's how I'm getting this NaCl. But I need to balance this reaction. So NaCl, there's 2 Cl's here, we need 2 on that side. Added 2 as a coefficient, which means we need 2 sodiums on this side, so we added 2 as a coefficient there. The next type is pretty much the same, except for we're specifically looking at a reaction with oxygen to form an oxide compound. So first example here, magnesium and oxygen. We're still going to have elemental forms here, so magnesium and oxygen combining to form magnesium oxide. Okay, and the formula for magnesium oxide, Mg has a charge of 2+, oxygen is 2-, so we crisscross and they cancel each other out to give us MgO. MgO, we need to balance this oxygen, there's 2, so we need 2 of those ones. That gives us 2 magnesiums, so we can put a 2 on the other side to balance the magnesium. Now magnesium oxide is a solid. When you have a metal and oxygen reacting together, they're going to form a solid metal oxide product. So another example here, lithium and oxygen. Again, the metal is always going to come first, so lithium and then the non-metal oxide. Lithium has a charge of 1+, oxygen is 2-. Crisscross is going to give us lithium oxide with Li2O like this. We have 2 oxygens here, we need 2 on that side. So again, add a coefficient. That gives us a total of 4 lithium. So we need a 4 in front of that one. The last type here is when we take a metal oxide and we react it with water. So you can have synthesis reactions not only with single elements, but also with full compounds reacting together to form a single product. In this case, a metal oxide, when it reacts with water, will always form a base. A base is a compound that contains hydroxide. So it's going to have OH as part of it. So here, magnesium oxide with water is going to form a base containing OH from the water, and it still has to include all the same atoms as we started with. So we had magnesium, oxygen, and hydrogen. So the only base we can form with magnesium, oxygen, and hydrogen is magnesium oxide. So MgOH2. So you see the magnesium, magnesium, hydrogen, hydrogen, oxygen, oxygen. So this is magnesium hydroxide. And these reactions will already be balanced if you do them correctly. So magnesium has a charge of 2+. Hydroxide is a polyatomic ion with a charge of 1-. When we crisscross those down, that brings the 2 out here. We need the brackets to indicate we have 2 whole hydroxides, not just 2 hydrogens. And then if we count it out, we have 1 and 1. Here we have 1, 2 oxygens, 1, 2 there, 2 hydrogens, and 2 hydrogens. Magnesium oxide, so bases, will always be aqueous. So it's going to get the subscript AQ. Okay. Forgot to put a solid on the lithium oxide there. That would be a solid. For some of these ones, these are both going to be solids as well. A lot of synthesis reactions form solids, but not all the time. So it kind of depends. If you have elemental forms reacting together, often it's going to form a solid. But there's some specific ones that you will need to know for sure. Like metal oxides are always solids. Bases are always aqueous. Okay, the last example here, another oxide compound. So metal oxide, calcium oxide, reacting with water is going to form calcium hydroxide. So again, I'm forming a base. Calcium has a charge of 2+, hydroxide is 1-. So crisscross is going to give us CaOH with a 2. And this is going to be aqueous as well because it's a base and we're putting it in water. Okay, and it's already balanced. So 1 and 1, 2 oxygens, 2 oxygens, 2 hydrogens, 2 hydrogens. Okay, so those are your major types. You've got elements combining to form a compound. You've got reactions with oxides, and then a metal oxide reacting to form a base. And we're going to do a little lab experiment where we're going to look at what happens when you put a non-metal oxide in water and what does that form, but we'll do that in class. The practice questions on the back of the page also, there's some practice questions there and some in the textbook, but we will do those in class.